Hello and a very good day. In this video, me, ALIA, SYAZANA and my partner, SYAHEEDA from Group 9 are going to present on the summary of an article about a multiple multi-layer perceptron neural network with an adaptive learning algorithm for thyroid disease diagnosis in the Internet of Medical Things. Here is the article that we referred to. This is the content of this video, which consists of introduction, objective, methodology, results, conclusion, and reference. The methodology part will be broken down into several subtopics. Now let's start with the introduction. The diagnosis of thyroid disease is an essential competency of medical information systems. The primary goal of this research is to enhance the thyroid illness detection. Firstly, artificial neural network, or in short, ANN, is an extensively utilized machine learning approach that mines the valuable sources of information of examination results and medical imaging for diagnosis purpose. Next, the multi-layer perceptron (MLP) is a fully connected class of feed-forward ANN. Despite the MLP's backpropagation accomplishment, there are still significant limitations such as low convergence and the local minima problem. And lastly, in this study, DMMLP, multiple multi-layer perceptron, is utilized to classify the thyroid disease sample into three main categories, which are normal, hypothyroid, and hyperthyroid. The backpropagation error in the proposed MLP is used to improve network generalization behavior. This is the objective in this study. First, to diagnose three types of thyroid disease using multiple MLP. Secondly, to improve the accuracy of classifying features selected from the dataset. Next, to achieve better results than previous research. And lastly, to improve the performance of ANN by using adaptive learning. Moving on to the methodology part. As we mentioned earlier, MLP is a common machine learning method. Several configurations on MLP will actually increase the accuracy of thyroid illness diagnosis. Other than that, an adaptive learning rate was proposed to improve the generalization and convergence rate of the proposed MMLP. So, the first subtopic is about the dataset. In this research, a thyroid illness dataset from UCI's machine learning repository was used, which involved 21 input variables from 7,200 patients, 15 binary, and 6 continuous features. The target variables include normal, hyperthyroidism, and hypothyroidism patients. Here is the figure showing the structure of the proposed MMLP. Proceed with the next subtopic, which is feature selection. A subset of important characteristics that have a favorable impact on classification accuracy is picked through the process of feature selection, which is also known as attribute selection. Feature selection allows the removal of irrelevant variables. The properties are presented in order of priority based on how valuable they are in the relation to the class. After they have been applied, each attribute's rank in each method is used to produce a score. In terms of Pearson's correlation values, 12 relevant characteristics were chosen for this experiment, since the features chosen by the Pearson's correlation approach generate the best classification result. Following feature selection, feature scaling is an important process in rescaling the feature values from a dynamic range into a fixed range. The value of characteristics is standardized into a narrow range to increase the classification accuracy. The next subtopic is neural network classifier. It consists of one or more hidden layers, followed by a layer of linear neurons. Through the hidden neurons, the input signals are applied in a forward manner from the input to the output. The network may establish non-linear and linear correlations between input and output vectors due to the hidden layer with a non-linear transfer function. The MLP neural networks with one hidden layer was employed in these investigations. With more than one hidden layer, classification accuracy may have improved. Nevertheless, overtraining is required, which results in overfitting. This figure shows the MLP structure with 12 inputs, 3 outputs, and 8 hidden neurons.
The next part of the methodology is the purpose MLP. Here, multiple MLP of the feed-forward neural network were applied. It has a function to eliminate overfitting and enhance the generalization of networks. In this design, 6 neural networks evaluate with individual MSE and the average MSEs of the network, which are then finalized into 6 ANNs for the combination. Backpropagation type of MLP is used as it can put a gradient descent method to lower the mean squared error of the resulting output and original output for every input vector. Here it is shown an example of the structure of MLP of neural networks with backpropagation that was taken from Ghaffari et al. 2014. The last part of the methodology used is adaptive learning rate. Adaptive learning rate can solve the problem with conversion rate in choosing the optimal value of learning rate by adapting the value of learning rate during the training process. Here, a step-based type of learning rate was implemented. A step-based learning rate sets a new learning rate based on the planning step. It shows the formula used in step-based learning rate, where NN is the learning rate at iteration N, and N node is the initial learning rate, D is how much the learning rate should change at each decrease, R corresponds to the decrease rate or how often the rate should be decreased, and lastly the for function here decreases the value of its input to 0 for all values smaller than 1. Now we shall see the outcome for this improved MMLP. Firstly, 21 input variables and 7,200 records taken from the UCI machine learning repository as the tiered datasets were chosen. In the data preparation procedure, 12 attributes were the most effective on accuracy classification. Next, the most accurate and best performance of the study was harvested by a set of networks with 12 input, 3 output, and 8 invisible neurons after all the 6 networks' accuracy and MSE being compared. Among the 6 networks, the most accurate is the last one with 94.4% accuracy and 0.0357 MSE. After applying MMLP, the accuracy rate increased by 4.6, 0.0249 MSE, and 0.06 R value. Besides, in narrow C, the MMLP has high accuracy for all the 3 classes. Moreover, it is found that the learning rate used to avoid overfitting shown value at epoch 818 is 0.55, and the MMLP with 6 networks produced the greatest performance with the stated learning value. When using the improved backpropagation with adaptive learning, the time taken for training a set of 6 networks was 3 seconds each. Finally, the learning process is well accomplished with reduced network errors of small finite MSE, decreased errors of all sets until epoch 818, no occurrence of overfitting, equal reduction of error in all sets, and no occurrence of lowering training sets error underfitting. We have come to the conclusion part for this type of design in diagnosis thyroid disease. In conclusion, an effective method to search for universal minima of the error function to determine convergence in the presence of local minima in IOMT environment should be given more focus in the future. Besides, the effectiveness of the proposed method should be proven using mathematical modeling by examining the former methods. Lastly, it could be seen that by using this design, the original thyroid dataset will be employed to search the proposed method and determine the ability of the method to diagnose thyroid disease. Here is the references used in this video. Thank you very much for listening.